Once again, welcome to our new session of Maths for Standard 9. This is chapter number 2, exercise 2.1. Earlier, my friend, earlier lecture we discussed that any expression becomes polynomial when and only when and the power of variable in each term of the expression is a whole number rather non-negative integer. Okay, so where the power of the variable can be 0, 1, 2, 3 or something like that. The power of variable cannot be negative, cannot be fraction. If the power of the variable is negative or fractional, then the given expression is not called the polynomial. Okay, so let us go for it and practice it. Which of the following expressions are polynomial in one variable and which are not? State reason for your answer. Okay. So 4x square minus 3x plus 7. Look at it. Here the first term 4x square, the second term is minus 3x and the third term is 7. Look at the power of variable in each term. X raised to 2 and 2 is a whole number. Okay, here minus 3x, the power of variable is 1, exponent rather. Exponent of the variable is 1 here and 1 is a whole number. And here it is, if nothing is there, it will be x raised to 0. And 0, the power of variable is, exponent of variable is 0 and 0 is a whole number. So in all the terms, the exponent of the variable is a whole number and that is why this one is a polynomial. So this one is a polynomial because the exponents in of variable in each term is a 1. Okay. So the exponent of variable in each term is a whole number and that is why this one is a polynomial in one variable. Now, is the y square plus root 3 is a polynomial in one variable or not? Look at it. Y raised to 2 is the power of variable 2 is a whole number and root 3 which is a constant and constant term has always the power of variable is equal to 0. Okay, so this one is also is a polynomial. Okay, you can write the same reason for that. So the exponent of variable in each term is a whole number here also, and that is why this one is a polynomial. Okay, look at it. See here, look at it. Root 3 can be written as t raised to 1 by 2. Okay, so root t can be written as t raised to 1 by 2. Root t is equal to t raised to 1 by 2. Now the power of variable is not a whole number. Okay, so this one is not a, this one is not a polynomial because the exponent of variable in the first term is not a whole number. this one here. See here, y 2 upon y is equal to 2 into y raised to minus 2. If the variable is there in the denominator, if we bring it to the numerator, its power will be negative. Means what? The power of the variable is negative here, and if the power is negative of the variable, then the given one is not a polynomial. Okay, so is not a polynomial. So you can write the same reason for that. The exponent in variable in the second term is not a whole number, the second term. And that is why this one is not a polynomial. It's exercise 2.1, question number 2. Write the coefficient of x square in each of the following. So we have to write the coefficient of x square. So find out the in each time, every time find out the term with 2 power of x square. Now coefficient is the number that is multiplied to x square. So you do not find here any number. So the number must be 1 here. Okay. If you don't see any number as a multiple of the variable, it is always 1 there. If it is negative sign, then it is minus 1 there. Okay. So plus 1, that's why it is 1 there. Now here 2 minus x square plus x cube. So coefficient of x square is here minus 1. Okay. Now here pi by 2 into x square plus x. Here is the term with 2 power of x is x square, and the multiple of this term is pi by 2. So the pi by 2 is the coefficient of x square. Okay, and here see, you don't see the term with x square here. If in a polynomial the term with x square is not there, then there must be a 0 to its coefficient. Its coefficient is 0, and that is why it is missing here. Okay, so coefficient of x square is 0. Now my friends, question number 3. Give one example each of a binomial of degree 35 and of a monomial of degree 100. So first one, we are going to do the example of binomial of degree 35. Okay, binomial of degree 35. So the binomial means there must be a 2 terms. Okay, and the degree of 35 means the maximum power of the variable must be 35, and there must be a term with a variable having 35 degree. Exponent of the variable must be 35 and not more than that. Okay, so it can be like this: 2x raised to 35 plus 5. So anything you can write here. You can write here the term the variable having less than 35 powers. Okay, so there must be a 2 term, and the highest exponent of the variable must be 35. And this is the example of binomial of degree 35. Now we want to give the example for the monomial of degree 100. Okay, monomial means the polynomial having only one term, and of the degree 100 means the highest exponent of the variable must be 100. Okay, so x raised to 100 is compulsory, only one term. You can write any coefficient here, let me write it be minus 5x raised to 100, and this is the example Question number 4. What is the degree of each of the following polynomials? Look at it. Degree of the polynomial. How it is determined? It is determined by the power of variable and the highest exponent of the variable in each term. Look at each term, and the highest exponent of variable becomes the degree of given polynomial. Look at it. X raised to 3, x raised to 2, x raised to 0. So the highest highest exponent of the variable x is 3. So this is the polynomial of degree 3. Okay. Now look at it. 4 minus y raised to 2. You can easily see that it's obvious that the highest exponent of the variable y is 2. So its degree is 2. Now look at it. 5t minus under root 7. Okay. See, the variable is here only and its exponent is 1. So the highest exponent of the variable is 1. So degree is 1. Okay. And look at it. This is a constant term. Constant term means you don't see any variable x, but it is there. It is 3 into x raised to 0. So every constant term has the degree is equal to 0. So the degree of every constant term is 0. Okay. Now my friends, classify the following as a linear, quadratic and cubic polynomials. So 7 polynomials are given here. We have to classify whether the given polynomial is a linear one or quadratic one or cubic one. So which is a linear polynomial? The degree of polynomial 1 means the highest exponent of variables in each term. You can find it is 1, then the polynomial is linear. And then the degree 2 polynomial is a quadratic polynomial, means the highest exponent of the variable must be 2, not more than that, and it is a quadratic polynomial. Then cubic polynomial means the degree 3 polynomial, the highest exponent of the variable must be 3. Now look at it. First one, x square plus x. The highest exponent of the variable is 2, and the 2 degree variable is known as a quadratic. Okay. Then x minus x cube. The highest exponent is 3 here. So the 3 degree polynomial is a cubic polynomial. Cubic polynomial. Third one, y plus y square plus 4. See, here y raised to 1, here y raised to 2, here y raised to 0. The highest exponent of variable y is 2. And this one is a 2 degree polynomial, degree 2 polynomial, and degree 2 polynomial is a quadratic. Okay. Then the next one is 1 plus x. See, the highest exponent of the power is 1. So the polynomial with 1 degree polynomial is known as linear polynomial. Okay. 3t, only one term, and the variable is having only one power. So the highest exponent of the variable is 1. So once again this one is a linear. Okay. Then it's a 2 degree polynomial, and 2 degree polynomial is a quadratic one. Okay. And this one is a 3 degree polynomial, and the 3 degree polynomial is a cubic polynomial. Okay. Very good.